Hello. These are the notes for 1.11. And we will be factoring again. Put the date that you're doing it on, just in case you were to lose it or something, and I find it. Names and dates are good. Our goal today is going to be how do I do a capital factor a difference of squares. And I'll let you get that written down, and then I have to do a little vocabulary for you. So, first of all, there's a whole set of numbers that we call perfect squares, and they're created by doing 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and I could do that on out to infinity, and I'll have a list of what are called perfect squares. And they're perfect because their roots are nice. The square roots of all these are 1, 2, 3, 4, 5, 6, 7. So they're really nice to work with. They're a number times itself. Well, also in our perfect squares is any variable times itself. So like x squared is considered a perfect square. So is y squared. Any even power is actually considered a perfect square because this one I could do x times x, y times y. This one I could do w to the second times w to the second. So all of these, and I could go dot, 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 are what we call perfect squares. Well, a difference is subtraction. So what a difference of perfect squares looks like is it's a perfect square, something times itself, minus, I'm going to pick this one, another perfect square. This is called a difference of squares. And when we factor them, they factor really nicely because they are created by doing something times itself in the front. X times x is x squared. Something times itself in the back. 5 times 5 is 25. And then there's no middle term. What that means is we have to add up to 0, which means we have to have one positive and one negative. You'll notice if I were to FOIL this right here, I would have firsts, which would be x times x, which is x squared. Then I'd have on the outside a minus 5x, and on the inside I'd have a plus 5x, and they would cancel. And then I'd end in a minus 25. So when we can spot a difference of squares, they're really easy to factor because we have samers out front and samers in the back with opposite signs. So they're really easy if you can spot them. So let's try another one. Y squared minus 100 is what we'd call a difference of perfect squares. It can be created by samers out front, y times y, and samers out back, 10 times 10. And then to create that wipeout in the middle, notice there's nothing in the middle there. There's no like plus 6y or anything that we're trying to add up to. What that means is we add up to 0. So we choose 10 and negative 10, and when we FOIL that, we get the original back. Keep in mind this is called the factored form right here. And this right up here is called a difference of squares. It's actually what we call a difference of perfect squares. So we have factored a difference of squares. So we're just going to do a few of them. They're pretty easy to work with, so they're way easier to factor than the other stuff you've been doing. So let's go take a look here, and let's do a little factoring examples. I'll do 3 of them, and that'll be it for this section of notes. After this, you'll be making a factor flowchart, and that'll be the next thing you need to do before you're ready actually for a practice test, because you will be done with your factoring part. So we'll run through this. You have one more green worksheet to do, and then you're ready to get ready for a test. All right, so here's my first example. These would say factor. And today we're going to have all differences of squares, so I'm going to go create a few. For number 1, let's just write them down first. For number 1, we're going to factor 25x squared minus 4. And leave some space. Let's go write number 2 down, so drop down a little bit. For number 2, we're going to do x squared minus 256. And last, for number 3, let's choose some different variables. How about if we do 49u squared minus 36v squared? Each one of these is what we'd call a difference, because of the subtraction, of perfect squares, because this is 5 times 5, this is x times x, and this is 2 times 2. This is x times x, and this is, oh, what if you don't know? You go to your calculator and you take its square root. If you were to go on the calculator and do the square root of 256, a 16 will pop out. So that's 16 times 16. This is 7 times 7. This is u times u. This is 6 times 6, and this is v times v. So when we break them apart, we structure it exactly as I just said it. What times itself gives you 25? 5 times 5. What times itself gives you x squared? X times x. So there's my samers out front. If I multiply those, I get 25x to the second. I know I need to end in a 4 and I need to have samers. So I choose 2 and 2. And then to create a middle wipeout, we do 1 plus and 1 minus. And we have factored a difference of perfect squares. Let's go look at the next one. In order to get x squared, I need to have x times x. Now I need something times itself that gives me 256. Again, if you don't know, you go grab a calculator. They're up on the top of that white worksheet box over by the refrigerator. And then we'd have 16 and 16. And again, we'd have 1 plus and 1 minus. And I would like you to try doing this one. So pause the video, go do it, and then come back and check it. So pause the video right now. All right, let's see how you did. So what times itself gives you 49? 7 and 7. What times itself gives you u squared? U and u. So there's a pair of samers that when I multiply them, I get 49 u to the second. And then in the back end of this, I can get 36 with 6 and 6. To get that v squared, I need to have v and v. So I've got samers out front, samers out back, and then I need to have 1 plus and 1 minus. And I have factored a difference of squares. So I'm not going to write a summary for this one, but you should go get your notes checked. And then you'll grab worksheet number 14. And it is green. So that's the next worksheet you'll grab, and that one will go pretty quickly for you. So over and out. No Girl Scout this time.